Okay, so this is the briefing for the Ruthenium experiment. What you'll be making in this experiment is this sort of metal ruthenium sort of complex. You'll be learning the theory about how these actually complexes form. You can see you've got that bond between the ruthenium actually in the middle of the aromatic ring rather than it being attached to a particular atom. Yeah, you'll learn about the theory about how these complexes form in your theory modules. The reason why we've given you this type of molecule to make is to actually show you that not all medicines are organic molecules. Molecules like this sort of ruthenium complex do also have biological properties as well. So it's to help you sort of appreciate that. And then the other sort of main purpose of this experiment is to give you practice, more practice of performing core synthetic skills. So many of these skills you performed before. But also, what's really, really important is actually helping you learn how to perform reactions on a perhaps much smaller scale than you're used to before. And this is because, for twofold, metals like these ruthenium complexes are expensive. To help keep the costs down, if you perform a synthesis at a low, small scale, then you can help keep the costs down. But also, when you send molecules off for biological testing, you only need 1 or 2 milligrams to actually be enough for an assay. So there's no need to actually make molecules sort of on gram scale if you only need small quantities as well. So it's a key skill for a medicinal chemist to be able to do synthesis on small scales. So this is kind of the overview of the experiment. So it can be conducted over a 2-day period, and we've got extra time sort of booked in for you if you do need a little bit longer for any portion of the experiment. The first step can be conducted in sort of the morning of day 1. It's a reflux workup, and then you've got your analysis. And then you can start part 2 in the afternoon, the reflux, and then the recrystallization. It recommends that when you cool your sample down, you leave your sample in the freezer overnight. So if you can get to this stage at the end of day 1, then that's what you should be aiming for. And then so in the following day, you can then filter your final ruthenium sample and then perform your analysis. Okay, so the tips then for this experiment all relate to the kind of extra considerations you need to sort of consider when working on it in a small scale. Okay, so you need to just be extra careful with all the steps when you're working on a small scale. Essentially, I'm sure you're used to, you can lose product, you can lose some of your sample and some of your product as you're performing certain procedures, particularly things like the liquid extraction, where you're sort of transferring things between conical flasks and separating funnels, for example. That doesn't matter too much when you're working on sort of gram scale. You still end up with a decent amount of material at the end. But when you're working on a small scale, if you're not taking really extra care to make sure you're transferring everything from flask to flask, then you're going to lose a lot of material quite quickly and you'll end up with nothing at the end of the experiment. So, as an example, okay, let's say you are running off your organic layer from the separating funnel to your conical flask, okay? Normally we advise as good practice to maybe rinse that separating funnel, so any compound sort of stuck in the separating funnel gets washed through into the conical flask. With a small scale, do this at least 3 times. Okay, anytime you transfer from something, so from one separating funnel to a conical flask, wash that separating funnel with some small amount of solvent 3 times. When you're filtering the mags with magnesium sulfate, wash out that conical flask 3 times. Wash that mag sulfate 3 times into your round bottom flask. If you're transferring your material out of a round bottom flask, wash that round bottom flask 3 times with solvent. If you get into the practice and habit of doing that, you should be able to transfer all your material and make sure you've got enough all your crude product that you should have. And then also, again, think about this with the recrystallization. We always say it's important to use a minimum amount of hot solvent. It really matters in this recrystallization that your solvent is hot, and you make sure you give the hot solvent enough chance to dissolve the product before you start adding extra portions, so that you don't add up too much solvent. The more solvent you add, the less product you'll get out at the end. And also then, if your final yield is quite low, don't forget at the end of the recrystallization, if you don't crystallize out as much product as you need, then you haven't lost the sample. It hasn't disappeared. It just remains dissolved in the recrystallizing solvent. So you can recover it. You can allow your sample to crystallize for longer, or what you're probably better off doing is actually reducing the concentration, or evaporating off some of the mother liquor that you used, and then with it more concentrated, you'll get more of your product to actually crystallize out at the end. You can get some extra material out. Okay, so those are the tips for the ruthenium experiment and the end of the briefing.